River Hydrology presentation by Taylor and Jack. What is river hydrology? River hydrology is the study of movement, distribution, and quality of water in rivers. River hydrology involves multiple factors. These include hydrologic cycle, river flow, watershed management, water quality, and hydraulic engineering. Example of these include the Nile River, which is located in northeastern Africa that flows into the Mediterranean Sea, which is the largest river in the world at 6,650 kilometers long. The Amazon River in South Africa is 6,400 kilometers long. The Congo River is the second longest river in Africa, as well as the third largest river in the world. Hydraulic, hydro, Hydrologic cycle. Hydrologic cycle is the continuous change in state of water. This cycle involves the various different states of water. These include liquid, vapor, and ice throughout the environment. The main components and process of hydrologic cycle include evaporation. Water from oceans, rivers, lakes, and other bodies of water is converted into water vapor by the heat of the sun. This water vapor rises into the atmosphere. Transpiration. Plants absorb water from the soil through their roots and release water vapor into the atmosphere from their leaves. This process is known as transpiration. Precipitation. When water droplets in clouds combine, precipitation. When water droplets in clouds combine and become very heavy, they fall back to the Earth's surface as precipitation, which include rain, snow, and hail. Groundwater flow. Water stored underground in reservoirs slowly moves through the soil and rock layers, eventually discharging into rivers, lakes, and oceans. As you can see in the photo, the background, there's all examples of this, of evaporation and groundwater flow, and ice getting melted from mountains.
River flow dynamics. River flow refers to the movement of water within a river channel, which varies significantly in patterns over time and space. This flow pattern plays a critical role in shaping the ecology of river ecosystems, influencing habitats for aquatic species and impacting the breeding, migration, and survival of flora and fauna. Moreover, river flow dynamics determine the movement and deposition of sediments, shaping river morphology and channel dynamics. In terms of water quality, the freshness of river flow is crucial for human consumption, and its dynamics affect the transport of pollutants, influencing water treatment needs. In conclusion, understanding and managing river flow dynamics are essential for preserving ecosystems, managing sedimentation, and ensuring safe water for communities. River hydrology and water quality. Some factors that may be influencing water qualities in rivers include runoff and population, stream flow dynamics, sediment transport, groundwater inputs, flood events, temperature and oxygen levels, and riparian zones. For the runoff and pollution, surface runoff and nonstop source pollution, such as pesticides and urban waste, introduce pollutants into water bodies. For the stream flow dynamics, high flow rates can dilute pollutants, while low flow rates concentrate them, affecting overall water quality. The sediment transport, the movement of sediment in rivers influencing both sediment levels and the transport of attached pollutants. For groundwater inputs, the groundwater entering rivers can alter river chemistry and contribute to the filtration of pollutants. For flood events, floods can increase pollutant levels and transport sediments and nutrients downstream, impacting water quality. Temperature and oxygen levels. Water temperature affects the dissolved oxygen levels crucial for aquatic life, influencing overall ecosystem health. The riparian zones, vegetated areas along riverbanks, riparian zones is what that means, plays a vital role in reducing runoff and erosion. thereby improving water quality through natural filtration processes.
Excuse me. What factors need to be considered when collecting drinking water from a stream or a river? When collecting water from a river or a stream, several factors need to be considered before you can drink the water and be sure that it is safe. Critical things to consider include water quality, access to the clarity, color, and odor of the water. Clear water is not always safe, but murky or foul-smelling water can indicate contamination. Source location. Collect water upstream from potential sources of contamination such as agricultural runoff, industrial discharge, sewage outflows, and areas with high human or animal activity. Chemical contaminants. Be aware of potential chemical pollutants such as pesticides, heavy metals, and industrial chemicals, which might not be visible or detectable without proper testing. Flow rate. Flow rate. Fast-moving sections of streams or rivers as segmented water is more likely to harbor dangerous chemicals. If you're not sure about the safety of the water, you should filter before consumption by boiling the water. Use water filters that are designed to remove bacteria or ultraviolet lights.
Watershed management. A watershed is an area of land where all precipitation drains to a common outlet, like a river, lake, or ocean. It includes the land and water networks that direct the flow to the point. For example, a mountain watershed is where areas where precipitation collects and drains from down mountainsides into streams and rivers. Urban watershed from city or suburban areas where rainwater drains into stormwater systems and local waterways. Forest watershed, forested regions where rainwater filters through the soil and drains into streams and rivers. Agricultural watershed, farmland areas where irrigation and precipitation drain into local water bodies. Coastal watershed, areas where water flows into coastal bays and oceans. And then lake watershed, regions where all water drains into a specific lake. As you can see in the background here, this is a picture of Melbourne, and it kind of shows how the land around is a watershed that falls into the peninsula. Hydraulic engineering. Hydraulic engineering involves the design and construction of structures aimed at managing and controlling water resources. Examples include dams, channels, levees, and floodgates, which are pivotal in regulating water flow and mitigating flood risks. This field integrates closely with river hydrology, which studies the movement of water within river systems, encompassing crucial aspects like runoff, stream flow, sediment transport, and flood dynamics. By leveraging insights from river hydrology data, hydraulic engineering optimizes the design and operational strategies of these structures, ensuring sustainable water management practices and enhancing resilience against floods.
When deciding whether to cross a mountain river, sorry, this thing's low way. What hydraulical attributes might determine the most appropriate crossing place? When deciding on where to cross a mountain river, there are various attributes that can help you make an appropriate and safe place to cross. These include water depth. Choose a section of the river where the water is shallow. Deep water can be hazardous, especially if it has a strong current or if the bottom is not visible. Flow velocity. Look for areas where the current is slower. Fast-moving water can easily sweep a person off their feet, even if it is shallow. River width. Opt for a wider section of the river. In wider areas, the flow is typically slower and shallower compared to narrow, concentrated sections. Presence of natural bridges. Look for natural bridges, such as fallen trees or rock formations, which might form a safer crossing without entering the water. Water clarity. Clear water allows for better visibility of the riverbed and any obstructual obstacles, making it easier to navigate a safe path across. Seasonal and weather conditions. Be aware of seasonal variations in current weather conditions. Snowmelt or recent heavy rain can significantly increase water levels and flow velocity, making crossing more dangerous. All these factors will give a person the ability to make a clear and safe decision.
Sorry. So, how does computer science and river hydrology kind of connect? So for some applications that you can see with computer science, there's data modeling and simulation. For example, utilizes computational models to simulate river flow, sediment transport, and water quality. There will be some data analysis. This will process large data sets from sensors, satellites, and field measurements to understand hydrological processes. The Geographic Information Systems, or the GIS. This maps and analyzes watershed characteristics, aiding in management decisions. Some advantages that you'll see with this is the efficiency due to the automates data collection and analysis, improving accuracy and speed. It has predictive capabilities, enables forecasting of floods, droughts, and water quality changes. There will be some decision support. Typically more it'll come from some AI aspects. It'll provide tools for informed watershed management and policy decisions. Some challenges that may be faced though, it might be maybe pretty complex, integrating diverse data sources and models. Accuracy, you may need to ensure models reflect real world conditions accurately, and interdisciplinary collaboration. This requires expertise in both computer science and hydrology for effective application. I feel like after this class, me and Jack will be able to do that. I hope you laughed at that one. And here are our citations. I'll give a few seconds for each one. And here are our citations for some of the images we used in the background. And that's the end of our presentation. Thank you for listening.
Thanks, Craig. Enjoy your day.
We can figure out how to stop it. There we go.
There we go.
Stop.
Stop.